Good morning. Welcome to the QCIS channel. We're on this channel. You get a daily dose of science, technology, engineering, and math. My name is Leon Jones, and what I'm going to do today is feature some information on a Proctor curve. Now, what is a Proctor curve? Well, look, Proctor curve was basically given a name by a resident engineer back in 1933 named Ralph Proctor. He used to work for the water department in the city of Los Angeles. Now, there are certain items that are included on the Proctor curve. And also, I want to show you the information that we use to run moisture tests. Because one area of inspection that construction inspectors, construction technicians, anybody who deals with testing, whether you're in the lab or the field, must understand is the paperwork. Anybody can run the test because they're procedures, but it's about where you put the data. What I'm going to do is show you some of this information. Now, I'm going to give you a few pieces of paper here. Now, remember I was telling you about the curve? Well, right here is the curve. Now, on this curve, there's some information that you need to see. Like, okay, the USCS, this is a classification system, and of course, you have AASHTO. Now, AASHTO has their code. I'm not as familiar with AASHTO, although AASHTO deals with highways. And of course, I work with highways. Now, when it comes to proctors, there are two types of proctors that you use. They're modified proctors and they're standard proctors. Now, basically, the proctor has a knob on the end, and you usually put it in a 4 to 6 inch collar, 3 blows, 3 layers, 25 blows apiece. Some of them are 5 layers, 56 blows apiece. Now, where do I get all the information? Well, I get all the information from soil passing through sieves. Now, let's go down here and look at what's on this chart here. Now, I'm familiar with the United States classification system of soils. So, whenever you see a word G always stands for gravel. And anything that has a G in front of it and a P, that means it's well graded. Now, you have coarse graded, you have well graded. Now, the GM is gravel, and that M stands for it's how much soil passed through what we call a sieve. Now, a sieve is made up of, it's a circle, and they have different size sieves. And each square in that sieve, a number 4 sieve, because that's generally what we use out here in the field, is 4.75 millimeters. Now, also what you see on this chart curve, you see a maximum dry density. Now, again, we have 2 different types of curves here. This one looks more like a modified proctor because the maximum dry density is a little bit lower than what it would be on a standard proctor. So they're giving you a maximum dry density and they're giving you an optimum moisture. This is the highest moisture, and usually when it comes to optimum moisture, you can be plus or minus 2%, I believe. Now, this is according to the ASTM specs. Now, also, you see these curves out here. Left, you have your dry density. Now, what's PCF stand for? PCF stands for pounds per cubic foot. Now, generally, water is 62.4 pounds per cubic foot. Now, remember, I said water because there's also seawater. Seawater is 64 pounds per cubic foot. Now, what you have your curves out here. Okay? Now, generally, you have your corrected and your uncorrected. Now, what you have here, the first curve that I'm running my finger, that's called your uncorrected curve. And generally, you have 5 points. Now, in the field, sometimes we may beat a 3 point, we may beat a 1 point, we may make our own proctors. And generally, when you make your own proctors, you have to have at least 2% water, and you beat basically 5 points. Now, in the lab, you beat 5 points. In the field, you need a quick proctor, a 1 to 3 point proctor curve, because you want to know what type of soil you have in it. On every construction site, soil is different. Now, again, going back here on this chart, you have your uncorrected and you have your corrected. So your corrected curve is this black curve right up top. It has all the information that is needed for you to run the test. Now, just so you'll know, to show you something, each proctor is different. You see, if you look at this one, the uncorrected, 6.9, where the first one was 5.3. And now the optimum moisture is a little higher and the maximum dry density is higher. Now, on these graphs, just to mention, I have what we call your water content in the percentage. So a point right here, this is 8. Now, sometimes to read these graphs, how much water do I have in this curve? So I can say, put 9 right in the middle. I can say right around 9.5%. Now, the way I read this and how do I find the dry density, I go up to where this first dot is, and then I go over, and it's going to give me roughly 120, almost 121. That's how you read these graphs. Now, it's very important on how you read these graphs. Now, also you have something called, I call it spec G. That's specific gravity. Now, you basically obtain specific gravity by doing a few things. You could you can look it up. There's a calculation for it, and this is what you do for all these tests here. You have to have this information before you can run any moisture density test. Now, also, what I have here is a report. Now, I'm going to interpret some numbers for you right here, because when you deal with soils, you have what we call LL and PL, your liquid limit and your plasticity limit. Now, when a soil is basically liquid, it's just saturated with moisture, with water. However, when it's plastic, your soil, basically you can roll it up into a tube and it looks like Play-Doh. Clay is an example of a plastic type soil. Now, because I'm familiar with the AASHTO testing method, let me tell you what ASTM D698 is, and I'm going to correlate it with the AASHTO. They call it the T99. ASTM D698 is what we call your, in the lab, we call it a standard proctor. Usually a standard proctor is about, you got 5 point, believe it's like 5.5 pounds. It's 5.5 pounds. That's a rammer. You can look at, you can see what that is if you're taking soil mechanics. But basically what you do, you grab it, you drop it. It's like a drop hammer. You drop it to compact your soil if you are using a 4 to 6 inch collar. The ASTM D698 is the same as the AASHTO T99. It's a standard Proctor. Now, the ASTM D1557 is your modified Proctor. You get about 18 pounds of dropping force when you're compacting soil in a 4 to 6 inch collar. Now, the ASTM D1557 is a modified Proctor. It is the same as your T180 if you're using AASHTO. Now, when you have any types of samples out here, this is a laboratory report. Well, because when we run tests, we want to know what we're running a test on. So basically, in order to get these chart answers, here's your modified Proctor, and here's your standard Proctor. Basically, all of the information is run in the lab. Now, this is your laboratory report. And what I'm doing, I'm going to be comparing my results to what the lab has done. So, what I have here are the results. Now, this is the summary results. Now, what did they do? Well, they ran a standard Proctor and a modified Proctor. And and also they ran what they call Atterberg limits. Atterberg limits is your plasticity limit minus your liquid limit. And basically, if your soil, most soils are, unless they're clay, because clay holds a lot of moisture, most of them are going to be non-plastic. And let me correct something. When I actually went in and did the first chart, okay, your first chart right here, this one right here is actually the standard Proctor right here. This is the standard Proctor. And this is your modified Proctor. Why? Because basically you see the shifts in the curves here. This is your moisture density report. And of course, this is your laboratory report. And right here, this is your summary. Now, after everything has been taken in the lab, here's what you come up with. Your results. For your standard Proctor, your maximum dry density is 134.2 pounds per cubic foot, and your optimum moisture is 6.3. That means this is the highest moisture you can obtain with this sample. Now, what is the sample? Well, going back to your lab report, the sample is NDOT number 53 crushed stone. Well, in PennDOT, we call it aggregate. It is aggregate. That's all the stone is. It's aggregate. And right here, we have 133.9. Now, when I do another video, I'm going to show you what the aggregate looks like. But what I'm doing is giving you some information on the paperwork, on how the paperwork works. Now, getting back to the information that I'm providing on the paperwork, it's your modified Proctor. Give you 133.9 and 4.9. This is a summary of what they got from your modified Proctor and your standard Proctor. Now, what we have here, if I was running a test, You have your test number. You have your station. And I will provide this when I actually run a test. And then you have tested on material passing. And that was number 53 aggregate. That was tested. Now, your aggregate for number 4 sieve must have at least 50% or more passing through the sieve. And then what you have to do when you first run a test, you have to weigh the pan. And once you weigh the pan, then you go ahead and you put the weight of the pan down in your column here. Then you have to put your wet material plus your pan in this column. And then you cook it off, you cook the moisture out, and then you weigh your dry material plus your pan. And then you find your weight of moisture by basically subtracting your dry material from your wet material. And then if you want your weight of dry material, you basically subtract your weight of pan from your dry material. And then if you want your percent moisture, you basically take your result of what you got from subtracting your dry material from your pan, from your wet material from your pan, and you divided it by what you got from subtracting your weight of pan from your dry material, and you multiply it by 100. And what you should get is your, depending on what proctor is being used, you should get 4.9 right around in that number, right around in that area, or 6.3. But when it comes to your paperwork, you always want your paperwork to be straight. And what I've given you is information on your paperwork for your moisture test. So again, if you're into soil mechanics, you're going to be running a lot of tests. So you need to know what types of reports you are using. So that concludes this topic on moisture density test reports. If you like what I just presented, of course, please comment, share, and subscribe. And if you're looking for some political and social content, you can check my other channel out, the 411 Talk Zone Radio Show channel. Now, if you cannot find the 411 Talk Zone Radio Show channel on YouTube, you can check both of those channels out on Twitter. Now, for the QCIS channel, since it is an educational channel, you can also find the QCIS channel on my LinkedIn page. And once again, thank you for viewing this content of moisture density reports right here on the QCIS channel. And on this channel, you get a daily dose of science, technology, engineering, and math. Until next time, my name is Leon Jones. I want you all to have a wonderful and gracious day.